So I'm going to share some of our preliminary findings from our research demonstration, which is funded by the Department of Energy and the CEC and a number of incentive programs. So folks that are from California probably be familiar with programs like TEC and maybe some of the rent incentives. So we work closely with AEA, another organization that you heard earlier in the presentation. We are the prime on some of these awards, and we are the sub on others. And my background is a lobbyist and a whole bunch of other things. And since I don't have my architect or structural engineer here, this presentation is going to reflect my ability to deliver information on some of these technologies. So if you have questions for folks that are engineers and I can't answer them, I'll have to just take them down and get back to you afterwards. So with that said, let's dive in. Okay, so I just talked a little bit about what we're going to cover today, but I just want to be clear. For folks in California, there are a number of electrification programs that already exist. Some of those are administered at our RENs or regional energy networks, so partnerships with utilities and municipalities, and others are offered through CCAs or our community choice aggregators. What makes our approach a little bit different is that when this program started way back in 1819, so I came in about halfway through the pilot demonstrations.
1919 or 1819?
1819, I think.
1819?
Well, Martha said the first conversations around funding were 18.
2018, 2019.
I'm sorry.
Yeah.
Not
So,
century.
oh, yeah. So sorry, guys. I just assumed here. So I came in halfway through a demonstration. So some of the pilot demonstrations were already done, so I took over for the remaining ones. And what's kind of different is that I think when the conversations were initially starting, there was this question, what's the most efficient and effective way to try and scale retrofit delivery? And we took an interesting approach, which I'll talk about, and be very forthcoming with the findings, where we are attempting passive house standards. So folks that know FIAS are going to be familiar with some of the terms I'm going to use, but if you don't, it's okay. I'll try and break it down into just simple building science. But all that means is we took a pretty aggressive envelope approach on the exterior. So we were looking at a model called Energy Sprong, which I'll talk about, which is derived from the Netherlands, and is an approach that they use to essentially scale a prefabricated panel approach to brick Dutch row buildings. It also had equipment electrification, some smart inverters and other cool features that I'll talk about that are also in our pilots. But just to kind of level set, we were a group that chose to look at what happens if you do aggressive exterior envelope interventions. So the theory of change is not unlike some of the other ones I've seen in the electrification space, but is important in terms of what we're trying to get back to the CEC on. So we want to standardize the package. We want to streamline financing. So for folks that are interested in talking financing, come meet with me afterwards because we have two briefs that came out of this. One is a managed energy savings account where we worked with some ESCOs to try and figure out their particular approach to efficiency upgrades. And the other one is tariffed on bill, so actually on the meter and looking at ways to try and address the split incentives. So I heard that term come out earlier today. It is a major barrier because it really is derived from this question of where should the benefits flow when you're going to electrify? Should it go to the building owner or to the tenants? And there are ways to do it, we think, with the tariff on bill approach. There are other states that already do it. And right now, the CPUC has been taking comments now for almost 2 years on what a program could look like if they were to provide pilot funding for a tariff on bill approach. And then lastly, scaling solutions means you've got to be able to scale delivery. That's actually one of the few areas where I think we've got something that would be helpful to continue to fund. And that's mostly because of a partnership with the state building trades. I'll talk a little bit about that at the end. But it's one of the more exciting components of the program. Really quickly, Energy Sprong, derived in the Netherlands. Here's some photos from their approach. Like I said, their approach is prefab panels, equipment electrification or swap outs. And the way that they pay for them is similar to kind of what we're looking at. So for folks interested also in payback period and length, paying for these is largely derived from heavy government subsidies and then accumulated savings over the course of a 30-year period with maintenance and repair savings as well. So these aren't cheap retrofits. There's some expensive components and quite an extended payback period, at least in this instance. But easier to scale for reasons I'll also talk about as opposed to the buildings that we're touching. So this is where we started. So this is the first slide that some of you probably saw when my predecessor, I think Amy gave a presentation at this very retreat like 3 years ago maybe?
So.
Okay. This is where it started. So as you can see, prefab envelope, that includes panelized roofing assemblies with integrated PV. Of course, equipment electrification for HVAC and domestic hot water, smart inverters, and we also have ERVs, HRVs that we try and incorporate into some of these technologies. I'm not going to spend a lot of time here, but this is kind of an interesting slide. Every electrification that I've seen over the years has some variation of this, and I think folks have talked earlier about this concept of how do you deal with some of these non-monetized benefits, so things like health benefits, indoor air quality. But the areas that I guess I'll highlight are takeaways that are kind of unique to this slide, because like I said, each electrification program has some variation of this. Are the partnership, again, with the building trades, which has an equity goal around minority, women, and disabled veteran business entities and their targeted recruitment. And then an area where I spend somewhere between 35% of my time, which is policy advocacy. So another thing that kind of makes our program unique is when I am not dealing with contractors on sites up and down the state, I am working with regulators to submit things like comments for structure around things like IRA contractor training programs. I wavered on whether or not to include this slide, but again, I'm going to show you all of our cards here because I want you to be able to have a realistic kind of eyes wide open approach to what this program is and what it isn't. This is a slide of modeled energy savings from Veracruz. So this was one of our pilot demonstrations in the Central Valley. And the big number that you'll see is that 63% modeled energy savings off a baseline. So for folks that are familiar with deep energy retrofits, you will see big numbers in modeled energy savings when they use EUI like we did. Most of it will be derived from areas, not surprisingly, HVAC, domestic hot water, and end plug uses. But that said, remember that number 63%, because when I got hired by RMI 2 years ago and saw that number, it raised some flags. So why affordable housing? I'm just going to level set here with the next couple of slides. And the simple answer is there's a lot of work there, and we think it's the most equitable way to approach decarbonization. So I guess the big takeaway here, there's two things. So we are looking only at deed-restricted affordable housing. That's only about a third of all the affordable housing inventory in California. What's the other two-thirds? Naturally occurring affordable housing. So folks that are familiar with the NOAA space, it is not one in which we are operating right now. We occasionally do have folks reach out to us, largely hedge funds and investors that are interested in kind of what I would refer to as the devil's work. So what that means is that they target properties that are at the end of covenant or end of affordability protection. And then what they do is come in and do minimal cap improvements before they then jack up the rents, and the property is no longer affordable for folks that are using housing vouchers, essentially. So if we just dealt with affordable housing and tried to meet the state's very ambitious climate goals, we would need to do about 45,000 units of some form of retrofit and deed restricted each year. Do folks know how big that is given the most successful weatherization program we have in the state right now? Raise your hand if you know the biggest. Yeah, I heard someone whisper it. LIWIP? Yes, LIWIP. How many units does LIWIP do on average? It's almost been the same since 2014, a year.
300.
More. Close. Very close. Close enough. 1,100, all right? So if the most successful weatherization or decarb program in the state does 1,100 units, and that's not just multifamily, it's everything, and we need to do 45,000 each year, you can kind of see we're going to have to either recalibrate on our end what's reasonable for a goal, or we're really going to have to get kind of a Hail Mary between this equitable building decarb money that's coming down the pipeline. I'll talk about that later. But really, there just isn't enough in place to hit that goal right now. Building typologies. So in targeting multifamily housing, we wanted to look at the areas where the most common building stock can be found. If you talk to an architect, they will probably debate all three terms, townhouse, garden style, and loaded corridor. But really, at the end of the day, what we're looking at are low-rise wood frame construction, primarily stucco siding. And the regions where you're going to see the most inventory are going to be the Bay Area and Southern California, not surprisingly. So where are the pilot demonstrations? So there used to be another site about right here. and that was Santa Ana, but we don't have that project anymore. So the answer is we've completed one in the Bay Area. That's East Palo Alto. That's known as Light Tree. AEA was the prime on that award. We were a sub. So my colleague, Gigi Merkel, who usually helps give this presentation whenever we mention Light Tree, isn't here. But if you're interested in a gut rehab all the way down to the studs with unitary and central systems for HVAC and domestic hot water, because they split the property, I can connect you with Gigi. We're actually looking at the M&V data from that site right now. And M&V, for folks that aren't in construction and pilot space, monitoring and verification. We have a 9-month period after we complete construction and tenants move in, where we are looking at energy savings, utility bills, and feedback directly from tenants. So it's interviews where we're asking, how's the equipment working? How's it working relative to what you had in here? And would you like to keep this? And a reason why that's important is because we usually have a backup system when we are deploying some sort of emerging technology. And it's really our safety net. So at the end of 9 months, if we have done something so terribly in that building, and I'll share a couple of the horror stories, we have the option of making it right for the tenant and the building owner. The other 2 demonstrations that are in the Central Valley right next to each other, Fresno is Kingsview Manor. That is under construction right now. Rich Grove, not that far from Fresno, is Veracruz. That one's done. So we're getting M&V from that one right now. And then my favorite headache, Corona, which is in the Inland Empire, but it's Corona del Rey. So I'll talk more about that one specifically at the end because that's the one I really want to dive into. So quickly, I'm going to go through the technologies that we have tried in one pilot or another. And I'm also going to have a product spec for CDR specifically. So for folks that want to wonk out and actually look at things like R values for walls and windows and all that, that'll be included on a sheet you can take a look at after we finish. So panelized roofing. One of the things that folks don't know about our demonstrations is the only one that has panelized roofing. And if you remember that earlier slide where we wanted to have panelized roofing with integrated PV, we only have a panelized roofing system in one building. And that is at Veracruz in Rich Grove. And for folks that aren't into construction, this is not a new technology. This does not qualify as emerging tech. Panelized roofing assemblies have been around since the 60s. You've probably seen them on schools or commercial buildings. Simple concept. You're really just taking steel or aluminum and you're sandwiching it in between an insulated core. What's helpful about them is that if you do them right, and I say do them right, if you can install them correctly, they solve a lot of problems for you because you're getting a pretty durable external panel that has essentially a panel liner that's already insulated. So if you can install these correctly, you also get a pretty decent life cycle compared to a traditional field installed insulated roof. So we can get almost 60 plus years out of these type of roofs when they're installed correctly. So for multifamily building owners, they really kind of like this product because roofing tends to be one of the areas when you're dealing with capital improvements where you tend to spend more time and resources, especially on larger properties. So roofs that perform well over time are preferable. Can anyone, based on these photos, tell me what's off about what I showed you earlier with the roofing panelized assembly that we wanted to deploy and what's not in this one? Or where's the PV in this?
Yeah, where is it?
It's not on the roof. It's on the carport running back behind. So here's another thing that's just what happens, I would say the difference between theory and practice. So in theory, we were going to do panelized roof assemblies with integrated PV on every pilot demonstration. Reality is that you have to go recruit building owners, and most of the time what you're trying to do is time a large capital improvements event or a recapitalization event. So in time when they're going to be spending a lot of money on a big building feature, and that tends to be things like roofs and carports. So with this particular building owner, when we came in and said, we've got these panelized roofs that are going to have PV, we walked the property and they said, we've already got PV. So in this case, there's no PV in this. So all we did, super high tech, was we just cleaned the panels before we left, and it just increased their efficiency. So that, not very techy. Air sealing. This is a minor headache, only because we're trying 3 different strategies. And coming from new construction, I was only really familiar with 2 of them, and that's hand-applied spray foam, which you'll see right here. That's pretty common. A lot of contractors know how to do that. It's not that expensive. If you're trying to achieve some form of higher building performance standard, maybe not the best. Sometimes it's not applied correctly, especially at corners and crevices. It tends to be an issue. So that said, we're also trying a liquid applied elastomeric. That's this blue one. Looks like paint. It's actually really easy to apply. It's pretty affordable. And then one of our challenges, which has been aero barrier, this aero seal that we have tried. Aero barrier's been around for a few years, so this product isn't new. It's still expensive. We've had challenges with contractors because they do have kind of a proprietary cloud system and installation method. So when you're looking at trying to deploy a package at scale, the last thing you want to have to do is negotiate something specific to a product that's already really expensive and might not be compressed, even if you can get volumetric scale. And that's kind of what we're running into with AeroSeal. So in a perfect world, we had the funding, we had the contractors that were ready. We would still have this issue of, what would the agreement look like to do thousands of these each year with them using their installation and their cloud system. And then on that bottom left-hand corner, if folks ask, well, why are you guys looking at 3 different air sealing technologies? On my end, I know when I came in, I wanted to focus on cost and the ability to actually install the thing in the field, because I'm surrounded by engineers and architects that want the newest, greatest thing out there. And that's fine, because this is a research demonstration. We need to try that stuff. But we're trying to hit passive house standards for leakage, so we want a really tight envelope before we size mechanical systems in PV. Walls and windows. Oh my God, panels, panels, panels. So one of the things about trying the energy sprung approach is these prefab panels, or these EIFS panels. And so we have an entire CEC award dedicated to funding these panels that are essentially going on the exterior of our Corona del Rey demonstration. Now, some of them come with windows, some of them don't. We are trying 2 types of wall panels. One is the Federlite, that's already commercially available. The second one is the Revitalight. The reason we are trying the Revitalight is we are trying to see if out of the 3 panel manufacturers we've identified, any of them can meet structural requirements in California. And we have found that the challenge in working with panel manufacturers is that all of them have essentially these great glossy brochures about products that they've only tested in their factories. So by the time you take it to the field, you get to kind of see where the rubber meets the road. So what you see right here to your right is a mock-up panel that we did in December after some really quick exterior demolition. But the gist of these is actually not that dissimilar to what I talked about with the IMPs. You're essentially getting foam and a fiber-grade composite material that is jammed between fiberglass rails and sealant. Now, Dextal, Stowe, the other 2 companies that make these 2, will probably say, Nick, there's more nuance than that. We have other proprietary things that go in, but that's basically what they are. And in theory, you should be able to use a 3D digital cloud point company or product to be able to help you map the envelope of the building. This is really important because it's been a major pain point for us. So we tried a couple different companies that had these awesome drones that came in and flew over the building, and we just stood out there, eyes wide open, just kind of like amazed that like we were going to have all this work done by this drone. And then over the course of the next several weeks, that turned into months, we found out the panel manufacturer was not comfortable using the digital scanning. So then we had to do the tried and true hand field verification, where we had to go back out and literally measure everything that the drone told us in terms of where the panel should fit. Bless you. And there's another reason why this is kind of a challenge from a project management or administration point. So usually when you do construction, folks have done construction projects, the holy grail is your construction set or the drawings. So when you're contracting, you are bidding out scope based on the drawings. The drawings, in theory, shouldn't be changing that much because you really want to protect yourself from change events that lead to change orders, which dip into your contingency. With a project like this, you also have panel drawings. So you have a separate set of drawings that outlines every single one of the panels by elevation and location. So what ends up happening, and this is another kind of just learning here, is that these are not, and I'll probably say this 4 or 5 more times before this is done, these are not Dutch row buildings, meaning we don't have perfect right angles at corners either. And we also have significant surface deviation. So if you were to just take brick, it's flat. It's easy for you to just have either an adhesive or a rail system you can attach essentially a load-bearing panel to. or even if it's not load bearing. But in our case, we do need load bearing. We're in California. But that's just not the case. We had to use also a service to figure out how much deviation would be acceptable, because again, these aren't flat buildings, and you really can't have part of the panel sticking out further than the rest of them. Aesthetically, it's a major headache, and quite frankly, you don't want to give the building owner something that looks terrible. But I'll talk about panels more again later. I can't speak to this one with too much authority because this is funded by a DOE award. These are supposed to be the holy grail or the future of what I'm kind of calling combi systems. So you can get domestic, you can get hot water, and you can get space conditioning out of one heat pump. We initially said we were going to have 4 of these in Corona del Rey. After some testing hiccups and also discussions with the manufacturer, which is the Systemair for that particular demonstration, we scaled back to 1. So I say all of that to say this product looked amazing when I first saw it last summer. And then having worked through testing and some long conversations with the manufacturer, this is one of the technologies I would encourage to not be in any package that could be deployed tomorrow. It still needs several years of work. But thankfully, DOE is funding that. And Brett Webster on our team heads up R&D. He's somebody I could connect folks with if they're interested in kind of learning more about the combi systems or the mechanical pods, because we're starting to see more manufacturers slowly kind of look at that model. But yeah, we are trying one of these. I will say one of the other challenges with these is that these do not fit in existing boiler or water closets. They are very big, and because you've got to route to a single destination and get outside too, you have to build a separate shed for them outside. So that's another thing that we weren't necessarily planning on. You've got to find a general contractor willing to come out and essentially take a shot on building. I mean, for ours, it's mostly just plywood, but it is kind of weird too aesthetically because it does sit out back behind the building. It's this big shed. So yeah, there's just kind of some things to be aware of with these mechanical pods. Won't spend a lot of time on HVAC. We're using heat pumps that most of you have probably seen and or used. The one nuance is the 3-in-1 with the HRV that we're trying at Veracruz right now, or the Rich Grove Central Valley demonstration.
Is that the IFOCA?
Yes.
Okay.
And the focus going into multiple demonstrations. We had that at Corona del Rey as well.
But with the ERV addition, I was just poking at that myself. So you're getting the one that has the ERV sort of built out on top of the heat pump.
Yes. So that's kind of new with the ERV. Same thing with, and I was talking about this earlier with you, and you're going to speak to this to more depth later with water heating, but we are trying both unitary and central heat pumps for water heating. AEA is primarily demonstrating the central systems. The only ones that I'm really working with at my Corona del Rey demonstration you'll see down here, and we were able to just take out the existing boilers and put them back in the closets. Again, anyone familiar with Bear Creek? It's a demonstration closer to UC Davis. All right, well, it's a demonstration where AEA's trying out a couple different central systems. So if folks want to wonk out on water heaters, I can connect you with that team over there. But yeah, again, some of these, the one thing also too that I'll point out here is that when we don't have, some of these don't have any electric resistance backup, so we need these to actually work because there really isn't an option like on our HVAC systems where we do have that choice. Okay, now CDR, let's dive into my biggest demonstration because it's got the most emerging tech in it. So these buildings were in bad shape when we got them. So remember earlier I was saying in the real world you would have these buildings that are ready to go, somewhat retrofit ready. These two buildings, 217 and 205 at CDR, are a great example of what it actually looks like to touch the building stock we're targeting. So there was no insulation, so that's roof or walls. This building was hot everywhere, so hot meaning there was asbestos and the exterior walls and the stucco. Also with the ductwork and the drywall inside. And what that means from a construction standpoint is once you touch walls and you get asbestos up in the air, you now have to call in a company to give you clearances or essentially make sure that that asbestos has been dealt with before you can come back in and work. So I've spent more time and money dealing with abatement contractors and companies to come in and do containment and clearances then I didn't even know this was really a thing coming from new construction until, so I got exposed to a whole new industry of contractors. But the thing that's especially painful about hot buildings is that once you've touched that asbestos, once it's in the air, everything gets shut down. All your trades are out of the building. They've got to come in and do containment and clearances. And so what that means is your master schedule, which is another thing you work off in construction, and you really need, there's two things that you got to adhere to: your budget and your schedule. And they're really, really intertwined. So we've had multiple instances where if it wasn't asbestos, it was termite damage. This building had termites in the walls and in the ground. So we had to also call a pest management company to come out, treat the building, shut down for a week. What's another thing we had? We had structural deficiencies. So we had missing seal plates, missing anchor bolts. Once we opened up the walls, we found just a shop of horrors. So we had to spend more money on structural engineering to come in and try and save studs. Again, stuff I'd never seen before. And stuff I think that when we were trying to explain to the CEC, this is why we still don't have walls closed up in this building. This is why the construction schedule's off. It was explaining the existing condition of the buildings. Two other just quick points on this building. Plumbing was a major, major problem. It went all the way back to the late 50s. The main water line for our buildings was about 40 yards into the street. So in order for us to come in and address some of the things the building owner wanted done, we had to coordinate with their plumber. So this is another thing I think when you're doing a retrofit. And remember I talked about timing it when there's a big capital improvement. What you want to do is find someone who's already spending money, preferably on something like a bunch of plumbing work. But what that also means is you've got to coordinate all of your scope with them. So when you're working on, so for example, we have all our walls open up right now. We're doing a bunch of drywall to close them now. But within that work, there's everything from dealing with the fact that they wanted new cabinets in the kitchens because they're doing interior fixtures mostly. So they're doing new tubs, new faucets, new sinks, new cabinets. It's the aesthetic stuff that tenants really like, but it's got to be coordinated because we ripped all the walls open and are doing new plumbing and new wiring. So for things like our condensate lines too, working with the plumber is really important. And the last thing was they're going to do PV, but at this particular site, the building owner has a full site rehab going on. So we're touching 2 buildings. The other 30 buildings are getting that kind of aesthetic lighter work I was talking about with plumbing. And the PV is going to come in at the very end. So they've got a 6-phase cap improvement project right now. So they're only in phase 2. We will be out of those buildings in December, which is only going to be like phase 3 for them. So they've got another 1.5 years of work. So the PV won't be up until really we're like done with M&V 2. So for folks that are like in the renewable space, that's a little frustrating for us because we won't really get to see what generation looks like once we're done, but there will be PV on those buildings. It's just not part of our scope. Again, if you want to go back and just kind of look at, I would say that to direct folks to the some of the things you're going to see at the bottom. So at 205 and 217, that's the gist of our scope right there. So you're seeing, and actually some of it up here too. You're seeing kind of what we're doing to the exterior of the building and what we're doing to the equipment. And then on the bottom, the building owner's just got a couple of scope items. But if folks were curious about things like air tightness, you can kind of see where we actually settled with code at 0.4 CFM at 75 Pascal. So we actually didn't hit a passive house standard there. So, and I say passive house, I'm surrounded by folks that are all FIAS certified. So that was kind of disappointing to a lot of them. But if you want to go back and just kind of look at it's kind of a spec sheet in terms of what we did, it's all here.
Did you find out what was leaking such that you didn't pass it? Where was the?
Well, so the first blower test door that we did actually hasn't been. I mean, that's what we were working off, and so we need to go back and do it again and see what we actually hit this time. All we did was alter the goal. So instead of trying to get passive house, we just said we'll just try and hit code because we weren't sure if we were going to hit the FIAS standard. Oh, okay. Well, I'm almost done. So in pictures, for folks that like visuals, I'm just going to quickly click you through what it looks like. This is what you get. This is the initial building, and it's not a Dutch row house, right? Look at all those shadings and awnings, and all that's got to be stripped off through demolition and abatement. So that next stage, you demo and abate all of that. You do your interior structural repairs, right? Open up your walls. And then you're able to come in and close up the envelope with your new windows. And in this case, we're just doing field applied insulated roof. It's not a panelized assembly. And at the very end, you get your PV. And of course, there's trellises and landscaping mixed in there. Here's just a picture of the panels getting fabricated within the Dryvit Tremco network. And again, I told you, it's a pretty simple design. I mean, if you guys really wanted to, one of you could probably go to grad school and create something really similar and have a patent in a few years. This is what they look like last December before we touched them, and this is what they're supposed to look like when they're done. See how those panels all sit what looks like flat? That makes me sleep better at night. And really quickly, what did we learn? How can it help you? What have I been saying? This is probably the fourth time I've said it. So our building inventory doesn't look like the Netherlands building inventory. I would, for lack of a better term, I would say their stock is much more retrofit ready, which of course is conducive to scale. Okay, here's just 2 pages of takeaways. Not surprisingly, existing conditions are a really, really, really big deal. So we have spent the last 2.5 months just looking at eligibility criteria and refining buildings we will and won't touch based on what we've seen in the pilots. So if you've got hot buildings, interior or exterior, major plumbing or structural deficiencies, and again, this is kind of hard with some building owners because not everyone has great records. You've got some guys that purchase these buildings in the last 5 or 6 years, and because of that transition during the sale, they don't have great MEP records. So sometimes you're flying blind. But to the extent that you can, know what you're touching before you select a building. Product readiness, there's certain technologies that just aren't ready to be employed in any retrofit package, at least in California. And right now that's prefab wall panels. I think they're more applicable to our East Coast team who's doing the same work in an area that's got much higher heating loads and condensation issues you could deal with between walls just based on temperature fluctuation. And then energy savings. So for folks that said you guys weren't going to do, you guys were heading down a wrong path years ago, you're probably right. The energy savings don't warrant this level of envelope intervention right now. So that number I threw out earlier, 63%, who knows what the actual, you already know, so you can't say anything. Who already knows what the actual number of savings or the average of savings on DER retrofits is, at least according to the latest white paper from DOE? What are they seeing across demonstrations? It's not 63. I'll just give you higher than that. 25 is where it starts. Where does it end? What's 40? Who said 40? Look at that. Those two right there. So 25 to 40. That doesn't mean there's not savings, but when you start looking at are the savings justified given the cost and the time that goes into the buildings, it's a different conversation. Workforce, just really quickly, we have a partnership with the state building trades we've been working on for months. We've sat down with them and identified some core trades that we'd like to have trained on the installation of some of our technologies that will make it into a final package. And again, our real goal here is to make sure we do a good job of utilizing their existing training facilities. That's the one thing right now, if you look across the board. We do have manufacturers that offer things like online module trainings for their technologies, but not sufficient. And of course, we're gearing towards this larger state rollout of equitable building decarb funding. There's almost $700 million there. And we think we're going to need a signatory network of contractors that can hit every part of the state as well. Labor brings that. And because we're looking at what will be a government program, there's going to be prevailing wage attached. So having worked with non-union contractors that I'm paying prevailing wage, I'd like to try the alternative. And that's just based on the rework or change orders I've had to deal with from folks that just haven't been trained well. And then just code and permitting, not a new thing for folks that have been in this space. When you are trying to get inspections or get someone to come out from a building department who's never seen a mechanical pod or one of these wall panels, it is kind of a challenge. We do have to oftentimes present letters from the funder, so the DOE and the CEC and the building owner saying this is a research demonstration. In 9 months, if these don't work, they're being replaced. And that's it. Appreciate you. Questions? I'll start here and then go to you.
What did you do for the tenants while you were doing all this work?
So where were the tenants?
Yeah, where did the tenants go?
This is a good question. I should have addressed this. So this only works if you have a larger portfolio owner who is able to relocate them during construction. because the alternative is you cover them with hotels, which is in no budget you're ever going to get funded by DOE or CEC. So the reason we were able to make this work is they had 32 buildings at CDR, and to be fair, we did say it's only going to take like a year, and it's now been 2. So you need the building owner to be, I'd say, a bit gracious with that type of situation, but it doesn't work for everyone. If you can't relocate people or rehouse them during construction, it's a no-go because it's too invasive, at least what we tried. But to be fair, if you did not touch the exterior, if you just went in with elastomeric and just electrified the equipment, you could get in and out of there pretty cheaply and pretty quickly. That's actually where I'm leaning, even though it upsets people in my camp. I want to see things that are closer to what's cost efficient, because we spent a lot of money trying stuff that didn't work that well.
What's your explanation for the difference between 63 and 45%?
You know, I wish I had a good answer for that, because when I saw that number, I thought it was a typo. I think what you're really seeing with some of these models, it's mostly the performance of the new equipment paired with a little bit of the tenant, just kind of tenant behavior. And part of what we're struggling with too is I don't think, and someone mentioned this earlier, like designing for climate change. So things like MERV filters on buildings were things that we didn't necessarily, or we haven't had to think about as much until these last few years, where now we're talking about our ventilation strategy has to have enough resiliency in it so that if there is a wildfire event, that we can essentially have folks in those buildings for a few days and they'll have decent indoor air quality. But yeah, I don't have a great answer for you, because I've seen, that's not the only slide like that. I mean, I've got my other demonstrations too where I've seen high 50s, and then when we actually get in and do the M&V, it's 26, you know? And if you're looking at like just using off the shelf, you know, whether it's air sealing or some of the other ways you can deal with leakage, there's a lot cheaper ways to do it. I mean, shit, zip tape and some other things that you do, it seems like some of that stuff, especially just getting tighter on penetrations, like that stuff's a lot cheaper than what we tried and just as effective. So.
You mentioned scalability, and I think that's a big challenge I've been seeing in the gas decommissioning and electrification projects. They all seem like they really need customized solutions.
Uh-huh.
What have you learned about scalability in our, or what have you learned about how not to achieve scalability?
Yeah, I feel like this is not a good presentation, because I'm telling you everything that didn't work. So I think part of what we do is we have unrealistic expectations in terms of how we define scale, right? Our own data said we need 45,000 units, right? If the most successful program in the state that already has a contractor network that building owners are already familiar with is barely doing 1,000, then I think scale needs to be thought of in terms of, and really I look at it as like what's actually funded and how long is it funded. That's why this equitable building decarb money is important. And then the other thing is just, and Sean and I have talked about this, if you're looking at historic buildings and some of these other things that just disqualify certain parts of the building stock, you need to think about scale in terms of like what's accessible to. Like, and it's not just like someone mentioned, like what do you do with the tenants? This really works for large owner operators or large portfolio operators. Like right now, having the ability to just something as simple as relocate 8 families for 4 months. If you're a smaller, you know, mom and pop, and a lot of building owners in multifamily in that NOAA space only own 3 to 5 properties. It's actually most of them. So they don't have the ability to relocate tenants while they do this type of work, which is another reason why once you open the walls and touch that exterior envelope, you got a whole series of problems that can only be dealt with by a handful of people.
I'd love to know more of your learnings on those hot buildings. So like we're working on buildings, or we are about to start working on buildings that we know will have asbestos, have a lot of mold, have all the structural issues. And you're saying, you know, leave those buildings alone to some extent when you're choosing, you know, for these kinds of pilot demonstrations. What about when that's the exact housing stock that you are trying to solve for?
That's an excellent question. So when I say leave those buildings alone, it means if the state's going to fund a program based on a package, then it can't touch those buildings. It doesn't mean those buildings don't need to be done. So when we're looking at how to spread out a large pool of funding, whether it's this equitable building decarb money or something else, because I know not all y'all are from California, we have to figure out how much funding should be dedicated to those. Those are high need buildings. Almost every building we have touched falls in that category. So you've got to provide some funding, but I think part of how you answer this question is you've got to find lenders that are also offering financial products to come in and help with some of these capital costs. And like I said, we have some briefs that I can walk folks through afterwards if you want to talk about tariff on bill or an energy savings account plan. But yeah, it's just those buildings, like if you wanted to sit down and walk through what's going to happen to your budget and your schedule, once you find mold, once you find pests, once you find asbestos, you're just going to have a much longer project, and there's going to be a lot of like uncertainties in there that you're going to have to, and it's going to be really expensive. I mean, that's the short answer is have a huge contingency and no end date for your construction schedule. That's how you deal with those buildings.
Great.
But no, I'd be happy to talk with you about and share vendors too, because you're going to have to price containment work and all that too.
So early on, you said that to get to some goal, you need to retrofit 45,000 within a year.
Until 2050.
Do you think the workforce is ready to hit that goal?
No.
So what do
No.
we need to do to hit that 45,000?
So this is why we're sitting down with the state building trades, because what we're trying to do is figure out who can train to that scale right now, and they already have training facilities, but more importantly, also who has a contractor network that can hit every part of the state. Because right now we do have contractor networks. RENs have contractor networks, CCAs do. It's not like they don't exist. But in order to hit scale, and this goes back to like, we need to kind of recalibrate what the goals might be. A realistic goal might be just to train in 3 regions for the first 3 years to get to a place where you can do 1,000 of these somewhere outside of the LIWIP program. And then scale up from there. But right now, there's no way we could do that. And labor still has never really, it's still not in this space. Like what we're talking about, again, I was talking about what's great in theory, not real in practice. Labor largely is non-existent in residential construction.
Are there available to get the workforce ready for this kind of work?
Well, the partnership with labor would involve where we do most of our vocational training in California, which is community colleges. So the partnerships where I think we could leverage those networks of students, folks that are potentially seeking employment fresh out of school. I know I'm past time. So we should talk about vocational stuff maybe offline, but no, the answer is no. We don't have the workforce to do that many retrofits right now. All right, Sean, I'm going to give it back to you so you can get someone else up here.
What are we gonna do?